So the second important theorem of Unit 5 is the extreme value theorem, or EVT. So the EVT guarantees that a continuous function on a closed interval will reach its highest and lowest points somewhere in that interval, even if those values occur at the endpoints. So let's go ahead and just draw a random quick example. Let's just say our function looks something like that. Let's say we're looking at it from here to here. So again, we're looking at a closed interval, right? So the EVT basically guarantees that if it's continuous on A to B, then this function will attain an absolute maximum and minimum value somewhere in that closed interval, and it's either going to occur at a critical point or an endpoint. So let's go through some key terms so that we're all on the same page of what we're talking about there. So as a refresher, the critical point is just where the derivative is equal to 0 or it's undefined. So looking at our graph here, that would give us this point here and probably that point there. It's a little hard to tell because obviously I just hand drew this and it's not very nice. Um, Second key term you may need to know is just the difference in local extrema and global extrema. So local extrema is basically a max or min that's within a smaller area, whereas a global extrema is basically the highest or lowest point on the entire interval. So let me just draw a quick example again, because I'm sure you love my drawings. Let's just say something like this. So if we were looking at this from here to here, this would be an example of a local min because relative to those points, it's a minimum, but it's not a global min because we have this point down here that's actually lower than that. So anyways, that kind of just demonstrates the difference in local extrema and global extrema. So going back to the EVT, let's talk about why it's useful. Basically, it assures us that extrema exist, so you're not going to be looking for something that isn't there. And then it's really the foundation for optimization problems, which are heavily tested on the AP exam. So that's like maximize this quantity or minimize this quantity, or minimize this quantity. And it helps us distinguish between local and global behavior, which is critical for the AP exam.